seeing. I like what I'm seeing. Good job, Ahmed. Good job. Push through. Come on, everybody. Push through. Push through. 10 seconds left. 10 seconds left. Come on. Put in the work. Work, 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 work. Come on. Come on. Ronnie, remember. Extend your jab. Extend your jab all the way. Extend your jab. Extend your jab, Ronnie. Remember that. Come on. Push through. Push through. 5, 4, 3, 2, 1, and break. Take a long break. Have some rest. We're going hard this session, huh? Excuse me. You're the coach around here?
Yeah, sure am, son. What you need?
Oh, great, because I was looking to, start a gym membership for boxing, you know?
Hey, coach. It looks like that one kid who won that math contest, eh?
Yeah, that popular one. Sure does look like him. He wants to apply for a membership? Man, stick to math, you nerd. You know, you won't ever make it in boxing, man. Get out of here. Get out of here.
Ronnie, don't say that.
We both know that you especially struggled when you started out here, okay? So you don't go making fun of other people. Alright? Go work your jab, man. Your jab sucks. Kid, don't listen to that douchebag. This is a sport that only requires hard work and dedication. It doesn't matter if you're poor, rich, a nerd, or a jock. Hard work and dedication. That's all it takes. And you said you're good at math, huh?
Yes, sir. I'm really good at math, not gonna lie.
Alright then. I know the perfect way to teach you boxing. We're gonna tie in your math skills with the boxing skills. And in the end, we'll make a great fighter out of you, huh? Does that sound good? So are you familiar with the Exponent laws or not?
To be honest, sir, I still haven't took them yet.
I feel you. So what we're gonna be doing is a method I like to call exponent destruction. It's where we combine your math skills with the boxing skills to make a great fighter out of you. Okay? So this is how we're gonna roll. First, I'm going to be teaching you the 5 exponent laws. Okay? Then, in order to integrate the boxing part with it, this is how you're going to be showing your answer and understanding. Let's say the answer to whatever exponent question you're given is 5 to the power of 3. Of course, it's evident that 5 is our base, and the 3 is the power of the exponent. Okay? So here's how exponent destruction works. Upon giving the question, you're going to be displaying your answer by saying the base out loud, so in this case it's 5, and the number of exponents, you're going to be hitting that number of punches on the back. So let's say it's 5 to the power of 3, that's my answer. Here's how it will look. 5. Now to get the exponent destruction, little Jim, this is how we're going to be destroying the whole amateur league here.
Yes, sir, I get it. Correct me if I'm wrong, but I say the base out loud, then I punch the number on the top, right? Which will be the power or the exponent.
That's right, little Jim. Now let's get to explaining the exponent laws, shall we? Okay, Jimmy, now let's start off with the product law. Of course, we know that the word product refers to a multiplication question, as we have right here. Okay? Now, what the product law is that it basically states that as long as I have the same base, which in this case I do have the same base, which is 5 and 5, I am eligible to carry that on into my answer. So I keep the 5 and I just add my exponents. Okay? This is all what it is, Jimmy. It's super simple. Okay? So I just separate my exponents and I add them. Okay? 14 plus 9. Which of course we know equals 23. So my final answer is 5 to the power of 23. Why? Because I have the same bases in my question, which is 5 and 5, so I just carry it on. And I just added my exponents, which is 14 plus 9, and the answer is 23. Therefore, my final answer, Lil Jim, is 5 to the power of 23. Now why don't you show me that in boxing fashion? 5 to the power. Okay, Jimmy. Now moving on to the second exponent law, we have the quotient law. Of course, you know that quotient refers to a division question as we have here. Okay, so what the quotient law basically states is that as long as I have the same base, I am eligible to subtract my exponent. And of course, the base carries on into my answer, and it would be to the power of the difference. Okay? So let's apply the quotient law. I can see that I do have the same base, which is 7. So this just carries on into my answer. Okay? Next, I look at my exponents or my powers. I can see I have 8 and 6. And as stated in the quotient law, I subtract them. So 8 minus 6 equals 2. So my final answer is 7 to the power of 2. Why? Because I carried over the 7, because I had the same base, and because I subtracted my powers. 8 minus 6 equals 2, so it's the power of 2. Now why don't you show me this answer in the boxing way, Jimmy? Okay, Jimster. So next up we have the zero power law. This is probably the simplest law you'll ever take in math in your whole life. It simply states that any number, even if it's 225,321 to the power of 0, it will just equal 1. Okay? As simple as that, it will just equal 1. If it's 335 to the power of 0, it will also equal 1. Okay? But now let's take a more complex example. So here we have 7 times 225 divided by 5 to the power of 0. At first, the numbers may seem very big and confusing, but trust me, Jimster, with the zero power law, it gets a lot easier. So as we stated, anything to the power of 0 equals 1. So in this instance, this whole bracket is to the power of 0. So therefore, I don't care what's in the bracket, okay? I can just cross that out. It equals 1, okay? And the 7 goes down with me. So I've simplified this equation to 7 times 1. Way easy, right? So therefore my final answer is just 7. Again, Jimster, any number or any bracket to the power of 0 equals 1. That's it. Moving on to our fourth power rule, we have the power rule, okay? What the power rule basically states is in order to raise a power to another power, we have to multiply them together. Why is that? Because I have 3 to the power of 3. And this whole bracket is to the power of 4. Okay? So I want to raise this power to another power, which is my 4. Okay? So what I basically do is I just multiply these two powers together. Okay? So the answer is going to be 3 to the power of 3 times 4, which then equals 3 to the power of 12. So 3 to the power of 12 is my final answer. Okay, so for our fifth exponent law, we have the expanded power rule. Okay? So what the expanded power rule basically states, it's pretty similar to the power rule, okay, Jimmy? Except it's expanded. That's the difference. So as you can see here, I have 3 times z to the power of 6, and that's in brackets. And all of the bracket is to the power of 2, okay? And as we stated in the last rule, if I want to raise a power to another power, I would have to multiply them, okay? So as you know, any number that's left on its own is automatically to the power of 1, okay? And these two powers, I want to raise to the power of 2. So what are we gonna do? We're obviously gonna multiply. So we're gonna multiply the 2 to the 1, and we're gonna multiply the 2 to the 6, okay? So what will be? It will be 3, 1 times 2 times z and 6 times 2, which would equal 3 to the power of 2 times z to the power of 12, okay? That would be my final answer. Now, Jimmy, show me this answer in boxing fashion. 3 to the power of times z to the power of Okay, Okay, Jim. I know this has been a long and hard training session, but trust me, all hard work pays off because we're finally at our final exponent law, which is negative exponents. Okay? So let's take an example. We have 11 to the power of negative 9. Okay? So what the negative exponents rule basically states is we switch our base to the reciprocal, okay? So as we know, any whole number is over 1, so it's 11 over 1. By switching it to the reciprocal, okay, it's going to be 1 over 11, okay? So I just write that down here, 1 over 11. But mister, you can't just leave the exponent behind. Right, Jimmy? Okay? So what do I do with the exponent? So upon moving my base down here, the exponent moves with it. But it just doesn't move with it. It turns into a positive, okay? So with that move, it turns into a positive. So now my final answer is 1 over 11 to the power of positive 9. Again, my final answer is 1 over 11 to the power of positive 9. Okay, Jimmy, now show me that in our good old boxing fashion. 1 over 11 to the power of